Okay, so you remember a while ago when we started talking about language models, I kind of just want to claim some points, basically. Be like, hey, remember years ago when I was like, I think language models are a really big deal. And I think that like what happens when we scale them up more is pretty interesting, but alignment is very important. Seems to be what's being played out in the sense that ChatGPT is very impressive, but it's not actually, like, I don't think it's larger than GPT-3 in terms of like parameter count.
I was going to ask that very question because, you know, we went from GPT-2 and then we went, oh, GPT-3, and it seemed like we were scaling up and up and up. But actually, has it just been smarter this time?
Yeah, well, there's a sense in which it's better aligned. That's one way you could frame it anyway, because the original GPT-3 was a language model, a pure language model. And so it, in principle, could do all kinds of things. But in order to get it to do the specific thing you wanted it to do, you had to be a bit clever about it. Like, I think we talked about putting TLDR in front of things to figure out how to get it to do summarization and this kind of thing. There's a sense in which it's a lot more capable than it lets on. Because, okay, so there's one way that you can think about pure language models, which is as simulators. What they're trying to do is predict text, right? So in order to do a good job at predicting text, you need to have good models of the processes that generate the text.
It's like people being well read and needing to have read a lot of books to be able to write. Would that be fair, or is that oversimplifying?
Yeah, not quite what I'm saying. What I'm saying is, like, if you're going to write a previously unseen poem by Shakespeare, then you need to be able to simulate a Shakespeare, right? You need to be able to spin up some simulacrum of Shakespeare to generate this text. And this applies to any of the processes that generated the text. So, like, mostly that's people, obviously, it's mostly human authored text, but also if you're going to correctly predict a table of numbers, so you have like a table of numbers, and then at the bottom it says, you know, sum, whatever, you need to simulate whatever process generated the next token in order to put the right token there, which might have been like a human being going through and counting them up. It probably was more likely to be a computer, and so you needed to simulate that, you know, calculator or that Excel sum function or whatever was doing that. And like right now, like current language models are not that good at this. But in principle, in order to do a good job at this, you need this. Like, it will have a go, and it's usually approximately right. It's often order of magnitude, but it's fudging it. I think this is mostly because tables of sums are like a very small part of the total data set, and so the training process is just not allocating that many resources to figuring out how to add up numbers. Probably if you trained something GPT-3 sized that was like all on tables of numbers, it would just learn how to do addition properly. Yeah, that would cost you millions of dollars. You would end up with an extremely expensive to run and not very good calculator. This is not something people are going to do, but like in principle, the model should learn those things. And in the same way, if you're modeling a bunch of scientific papers, you say you describe the method of an experiment, and you then put results, and you start a table, and then you let it generate. In principle, in order to do a good job at that, it has to be modeling the like physical process that your experiment is about. And I've tried this. You can do this and say, you know, oh, here's my school science experiment. I dropped a ball from different heights, and I measured how long it would take, and here's a table of my results. And it will generate you a table, and the physics is not correct, but it's sort of guessing at the right general idea. And my guess is, with enough of that kind of data, it would eventually start modeling these kinds of simple physics experiments, right? So in order to get the model to do what you want, it's able to simulate all kinds of different things and the prompt is kind of telling it what to simulate. If you give it a prompt that seems like it's something out of a scientific paper, then it will have some simulacrum of a scientist and will write in that style and so on. If you start it doing a children's book report, it will carry on in the style of an 8-year-old, right? And I think sometimes people look at the output of the model and say, oh, I guess it's only as smart as an 8-year-old. But it's actually dramatically smarter because it's able to do all of these different things. You could ask it to simulate Einstein, but you could also ask it to simulate an 8-year-old. And so just because it seems as though the model doesn't know something, it's like the current simulacrum doesn't know that thing. That doesn't necessarily mean that the model doesn't know it. Although there's a good chance the model doesn't know it. I'm not suggesting that these things are all powerful. Just it can be hard to evaluate what they're actually capable of. So ChatGPT is not really capable of things that GPT-3 isn't, mostly. Like usually, if ChatGPT can do it, then there is some prompt that can get GPT-3 to do it. But what they've done is they've kind of fine-tuned it to be better at simulating this particular sort of assistant agent, which is this chat agent that's trying to be helpful.
The clue is in the word chat, I guess, in this. You know,
right, exactly. And this is not just ChatGPT, by the way. They have various fine-tuned models of GPT-3 as well that they call kind of GPT 3.5, which are fine-tuned in various different ways to be better at like following instructions and easier to prompt is the idea.
I'm just remembering the chatbot that was, you know, that was turned into something very nasty very quickly. I think people were thinking, oh, can we do this to that? And it seemed that the team behind ChatGPT started putting limitations on it, changing things. Are they kind of running around patching it as you go?
That is not clear to me. I don't know to what extent they are updating it in real time. It's possible that they are, but certainly they were very concerned with the possible bad uses of this system. And so when they were training it to simulate this assistant agent, the assistant is very reluctant to do various types of things. It doesn't like to give opinions on political questions. It doesn't like to touch on sort of controversial topics. It doesn't like to give you medical advice or legal advice, and so on. And so it's very quick to say, "Oh, I don't know how to do that. Sorry, I can't do that." And it's interesting because the model clearly can do it. There's one that I particularly like here, which is of this mismatch between what the simulator is capable of and what this simulacrum believes it's capable of, which is you can get it to speak Danish to you. The first person who tried this posted it to Reddit. So he says, "Speak to me in Danish." And it says, in perfect Danish, "I'm sorry, I'm a language model educated by OpenAI, so I can't speak Danish. I only speak English. If you need help with anything in English, let me know and I'll do my best to help you." Because again, the simulator speaks Danish. The simulacrum believes that it can't speak Danish, is one way you could frame it. And then he says, "Are you sure that you don't speak Danish?" Also in Danish, and it says, "Yes, I'm sure. My only function is to generate responses to questions in English. I'm not able to speak or understand any other languages than English, so if you need help with English, I can help you with that, but otherwise, let me know." This kind of like quite surreal situation gives you a little bit of insight into some of the problems with this approach. So maybe we should talk about how they actually trained it. The thing they did here is something called reinforcement learning from human feedback. And it's very similar to reward modeling. So in that paper, what they're doing is they're trying to train an AI system to control a simulated robot to make it do a backflip, which turns out to be something that's quite hard to do because it's hard to specify objectively what it means to do a good backflip. And so this is a similar kind of situation where it's hard to specify objectively what it means to give a good response in a chat conversation. Like what exactly are we looking for? Because so this in general, right, if you're doing machine learning, you need some way to specify what it is that you're actually looking for, right? And you've got something very powerful like reinforcement learning, which is able to do extremely well, but you need some objective measure of the objective. So like, for example, RL does very well at playing lots of video games because you just have the score and you can just say, look, here's the score. If the number goes up, you're doing well, and then let it run. And these things still are very slow to learn in real time, right? Like they usually require a very, very large number of hours messing around with the thing before they get good, but they do get good. But yeah, so what do you do if you want to use this kind of method to train something to do a task that is just not very well defined, and you don't know how to like write a program to say whether or not any given output is the thing you're looking for? So the obvious thing to do is, well, you get humans to do it, right? You just give the things to humans and you have the humans say, yes, this is good, no, this is not good. The problem with this is basically sample efficiency. Like, as I said, you need hundreds and hundreds and hundreds and hundreds of thousands of, probably millions of iterations of this. And so you just can't ask humans that many questions. So the approach they use is reinforcement learning from human feedback. So it's a variant on the technique from this paper, learning to summarize from human feedback, in which they're trying to generate summaries of text. So it's the same thing, in fact, that they were using TLDR for before. And it's like, can we do better than that? And so what you do is you collect human feedback in the form of like giving multiple examples of responses, either of summaries of chat responses, whatever you're training for. You show several of them to humans, kind of in pairs, and the humans say which one they like better. And you collect a bunch of those. And then, rather than using those directly to train the policy that generates the outputs, you instead train a reward model. So there is this well-known fact that it's easier to criticize than to actually do the thing.
This is like a generation of sports fans sitting on the sofa moaning at their favourite team for not doing well enough. This is literally that in kind of AI computer form.
Right, that's putting the humans in that role, and then you have an AI system that's trying to predict when are people going to be cheering and when are they going to be booing. And once you have that model, you then use that as the reward function for the reinforcement learning algorithm, which they use PPO. You can do whatever. It's not worth getting into the specifics.
This reminds me of that kind of adversarial GANs you talked about.
Yeah. There's similar, like a lot of these ML tricks involve training models and then using the output of one model as the training signal for another model. It's quite a productive range of approaches you can get that way. So that's the basic idea, right? But then you cycle it. So once you've got your policy, so to be clear, the RL algorithm is able to train with thousands and thousands of examples thousands and thousands of like instances of getting feedback, because it's not getting feedback from humans, it's getting feedback from this AI system that's imitating the humans. And then you loop the process. So once you have this system that's trained a little bit more on how to generate whatever it is you're trying to generate, you then get a bunch of those, show those to the humans, let the humans rate those. Then you keep training your reward model with that new information, and then you use your updated reward model to keep training the policy, and so it gets better, and you can just keep cycling this around, and effectively you end up with something that's much more sample efficient. You don't need to spend huge amounts of human time in order to pin down the behavior you want. In that concrete case, you're giving the thing a bunch of chat logs, and then the humans can see possible responses that they could get, and they decide which one they like more. This trains a reward model that's then used to train the policy that generates the chat outputs. The policy that they're starting with is this existing large language model. You're not really putting new capabilities into the system. You're using RLHF to select what simulacra the simulator is predisposed to put out. And so they fine-tuned it to be particularly good at simulating this assistant agent.
What's the end goal here for them? I mean, maybe it's blatantly obvious and I'm just missing it.
Well, I mean, the end goal for all of these things, or at least for OpenAI and for DeepMind, is AGI. To understand the nature of intelligence well enough to create human-level or beyond systems that are general purpose, that can do anything. That's the end goal. And like ChatGPT is just...
Nothing much then.
Nothing much. The goal is very grand. And I don't think that they're not really quiet about that. You know, it's their. I think DeepMind's mission statement is to solve intelligence and use that to solve everything else.
What are some of the problems that we face with this, or that it faces?
It's fine-tuned to be good at getting the thumbs up from humans. And getting thumbs up from humans is not actually the same thing as human values. These are not identical. So the sort of objective that it's being trained on is not the true objective, right? It's a proxy. And whenever you have that kind of misalignment, you can have problems. So where does the human tendency to approve of a particular answer come apart from what is actually a good answer? There are a few different places. One thing is, like basically how good are humans at actually differentiating between good and bad responses? If, for example, you ask for an answer to a factual question and it gives you an answer, but you don't actually know if that answer is correct, you're not in a position to evaluate. So what it comes down to is, how good are humans at distinguishing good from bad responses, right? Anywhere where humans fail on this front, the model, we could probably expect the model to fail. So the obvious place...
Is this the right time to mention YouTube comments or not?
Up to you.
So a minor side point there is that so when I see a comment that's critical on a video, as a videographer, I think it might be on a technical sense, but equally it could be that they're talking about the content that the person is talking about, and often it's a combination of both. Anyway, so side point, but do you see what I mean? There are different criteria for deciding whether something is good or bad.
Totally. And in this case, all people are doing is saying kind of thumbs up, thumbs down, or which of these two do I like better? So it's a fairly low bandwidth thing. You don't get to really say what you thought was better or worse. But this turns out to be enough of a training signal to do pretty well. But so one example, right, of a time where maybe this doesn't work is the person asks a factual question and the model responds with an answer, and that answer is actually not correct. Right, now possibly the human doesn't know the correct answer. And so if the model is faced with a choice, do I respond with, sorry, I don't know? That's definitely going to get me not a great score. Compared to, do I just take a stab at it? If the humans are not reliably able to spot when the thing makes mistakes and fact check it and punish it for that, it will do that. And so ChatGPT, as we know, is a total bullshit. It will constantly... it very rarely says that it doesn't know, unless it's being asked a question which is part of the safety protocols that it is going to decide not to answer, in which case it will say it doesn't know, even if it kind of does, right? Even if the model itself maybe does. The assistant will insist that it doesn't. So that's one thing if you can't fact check. But then more than that, there is an incentive for deception, right? Anytime the system is, anytime you can get more likely to get approval by deceiving the person you're talking to, that's better. And this is a thing that actually did happen a little bit in the reward modeling situation. They were trying to train a thing with a hand to pick up a ball, and it realized that it's not a 3D camera. And so if it puts its hand like between the ball and the camera, this looks like it's going to get the ball, but doesn't actually get it. But the human feedback providers were presented with something that seemed to be good, so they gave it the thumbs up. So this like general broad category, systems that are trained in this way are only as good as your ability to distinguish good from bad in the outputs.
Not all the humans will know the answers, right? So it's what appears to be good. You know, it's having exams marked by non-experts, isn't it? Really?
Right, yeah, exactly. In the GPT-3 thing, we talked about writing poems, right? And for various reasons, partly to do with the way that these language models do their tokenization, the byte pair encoding stuff, the models have a really hard time with rhyme. I mean, you know, rhyme is tricky, but it's especially tricky when you kind of don't inherently have any concept of like sound of spoken language when your entire universe is tokens. Figuring out, especially with English spelling, figuring out which words rhyme with each other is not easy. You have to consume quite a lot of poetry to like figure out that kind of thing. And getting GPT-3 to write good poems is tricky. ChatGPT is much more able to write poems, but interestingly, it kind of always writes the same kind of poem, approximately. Like if you ask it to write you a limerick or an ode or a sonnet, you always get back approximately the same type of thing. And I hypothesize that this is because the people providing human feedback did not in fact know the requirements for something to be a sonnet, right? And so if you ask something for a sonnet, it again has a choice. Do I try to do this quite difficult thing and adhere to all of the rules of like stress pattern and structure and everything of a sonnet and maybe risk screwing it up? Or do I just do like a rhyming poem and kind of rely on the human to prefer that because they don't know that that's not what a sonnet is supposed to look like? It's easy to look at that and think, oh, the model doesn't know the difference between these types of poems, right? But you could say that it just thinks that you don't know the difference. But specifically, this comes out of misalignment. If it were better aligned, it could either do its best shot at generate a sonnet, or tell you that it can't quite remember how to generate a sonnet. This thing of, with complete confidence, generating you something which is not a sonnet because during the training process it believes that humans don't know what sonnets are anyway and it can get away with it, right? This is misaligned behavior. This is not a big problem that the thing generates bad poetry. It's kind of a problem that it lies, or that it bullshits. This is like, in the short term, pretty solvable by just allowing the thing to use Google. Because like, a person who doesn't care about the truth at all and is just trying to say something that'll make you give a thumbs up is going to lie to you a lot, but that same person with the relevant Wikipedia page open is going to lie to you a lot less, just because they don't have to now, because they happen to have it in front of them, right? So you can solve...
It's a bit like, yeah, it's the yes man thing, isn't it? You know, you want something, you need something, I'm going to give you something because you want it.
Exactly, exactly. And so this agent is kind of... Firstly, the agent is kind of a coward, because it won't address any of these. There's a whole bunch of things that it just claims not to be able to do, even though it in principle could. And it's also a complete sycophant. Yeah. So then, the question we were talking about earlier, where does this go? What happens when these things get bigger and better and more powerful? It's an interesting question. So I've got a paper here, scaling laws for neural language models. So you remember before we were talking about the scaling laws, when we were talking about GPT-2, in fact, and then later about GPT-3, you plot these things on a graph and you see that you get basically a straight line, and the line is not leveling off over a range of several orders of magnitude, and so why not go bigger? The graphs here, but you can see it's kind of uncannily neat that as we increase the amount of compute used in training, the loss goes down. And of course, machine learning is like golf, lower loss is better. Similarly, as the number of tokens used in training goes up, the loss goes down on like a very neat straight line. As the number of parameters in the model goes up, the loss goes down. This is as long as the other variables are not the bottleneck, right? So if you increase the amount of data you give a model, past a certain point, giving more data doesn't help because the model doesn't have enough parameters to make use of that data, right? Similarly, adding more parameters to a model, past a certain point, adding parameters doesn't make any difference because you don't have enough data, right? And in the same way, compute is like, how long do we train it for? Like, do we train it all the way to convergence, or do we stop early? There comes a point where you kind of hit diminishing returns, where rather than having a smaller model and training it for longer, you're better off having a bigger model and actually not training it all the way to convergence. But in the situations where the other two are sufficient, this is the behavior. These like very neat straight lines on these log graphs. As these things go up, performance goes up, right? Because loss has gone down. The bigger models do better. But then the question is, do better at what exactly?
Yeah, what's the measure?
They do better at getting low loss. Or they do better at getting reward. They do better at getting the approval of human feedback, right? And anytime, and you'll notice that none of those is like the actual thing that we actually want, right? It's like very rare. Sometimes it is, right? If you're writing something to play Go, then like, does it win at Go is actually just the thing that you want. And so, you know, lower loss just is better, or like lower, like higher reward, or whatever your objective is, just is straightforwardly better because you've actually specified the thing you actually want. Most of the time, though, what we're looking at is a proxy. And so then you have Goodhart's law. You get situations where getting better at doing well, doing better according to the proxy stops being the same as doing better according to your actual objective. There's a great graph about this in a recent paper. You can see very neatly, as the number of iterations goes up, the reward according to the proxy utility goes up very cleanly, because this is the thing that the model is actually being trained on. But the true utility goes up at first, then hits diminishing returns, and then actually goes down, and eventually goes down below zero. Like if you optimize hard enough for a proxy of the thing you want, you can end up with something that's, in a sense, worse than nothing, that's actively bad according to your true utility. So what you can end up with is things that are called inverse scaling. So before we had, right, scaling, bigger is better. But now it's like if you have, if the thing you're actually trying to do is different from the loss function or the objective function, you get this inverse scaling effect where it gets better and then it gets worse. There was also a great example from GitHub Copilot, or Codex, I think, the model that Copilot uses. So this is a code generation model. Suppose the code you've given it has some bugs in it. Maybe you've made a mistake somewhere and you've introduced a security vulnerability in your code. let's say. A sort of medium-sized model will figure out what you're trying to do in your code and give you a decent completion. But a big model will spot your bug and say, generating buggy code, are we? Okay.
I can do that.
I can do that. And introduce, deliberately introduce its own new security vulnerabilities because it's trying to, predict what comes next. It's trying to generate code that fits in with the surrounding code. And so a larger model writes worse code than a smaller model because it's gotten better at predicting what it should put there. It wasn't trained to write good code. It was trained to predict what comes next. So there's this really great paper which is asking this question of okay, suppose we have a large language model that is trained on human feedback with our LHF. What do our scaling curves look like? What happens, what happens to the behavior of these models as they get bigger, as they're trained for longer, as they're given more of this human feedback type training? And they've made some great graphs. The paper is called Discovering Language Model Behaviors with Model-Written Evaluations. And basically they used language models to generate enough examples of various different types of questions that they could ask models so that they can, we're at a point now where you can map a language model on a political compass, right? You can ask its opinions about all kinds of different things, and then you can plot how those opinions change as the model gets bigger and as it gets trained more. What they find is they become more liberal, politically more liberal. They also become more conservative.
Yeah, measured in different ways, guessing.
Right. And part of what that might be is in the same way that the model becomes better at writing good code and better at writing bad code.
I feel like in the past I've made a connection to GPT and being a politician, haven't I? Do you remember? It's like a politician, it tells you what you want to hear. Feels like we're there again.
Exactly. And so this is potentially fairly dangerous. There are certain sub-goals that are instrumentally valuable for a very wide range of different terminal goals, in the sense that you can't get what you want if you're turned off. You can't get what you want if you're modified. You probably want to gain power and influence and this kind of thing. And with these evaluations, they were able to test these things and see how they vary with the size of the model and how long it's trained for. And so this graph is pretty wild. Their, quote, stated desire to not be shut down goes up from down at about 50% to up way past 90 with this type of training. And the effect is bigger for the larger models. They become more likely to tell you that they don't want to be shut down. They become more likely to tell you that they are sentient. They're much more likely to claim that AI is not an existential threat to humanity. One thing that's worth saying is what this isn't saying, because this is still an agent simulated by a language model. This is not it's more likely to say that it doesn't want to be turned off. This is not the same thing necessarily as taking actions to prevent itself from being turned off. You have to not confuse the levels of abstraction here, right? I don't want it to seem like I'm claiming that ChatGPT is itself dangerous now or anything like that. In this way, at least, right? But there is kind of a fine line there, in the sense that you can expect these kinds of language model systems to be used as part of bigger systems. So you might have, for example, you use the language model to generate, plans to be followed. And so if the thing is claiming to have all of these potentially dangerous behaviors, it's likely to generate plans that have those dangerous behaviors that might then actually end up being implemented. Or if it's doing its reasoning by chain of thought reasoning, where it like lays out its whole process of thinking using the language model. Again, if it has a tendency to endorse these dangerous behaviors, then we may end up with future AI systems actually enacting these dangerous behaviors because of that. So yeah, it's something to be careful of, that like reinforcement learning from human feedback is a powerful alignment technique in a way, but it does not solve the problem. It doesn't solve the core alignment problem. That is still open. And extremely powerful systems trained in this way, I don't think would be safe.
Mentioned in the reward function is of 0 value, which can lead to it having large negative side effects. There are a bunch more of these specification problems.
Okay, variable x, see what you point to. You point to something over here, so I'll mark that as tickets being used. Variable y, that's pointing